Hello all, very welcome to Talk GCSE, where I'm going to talk about Physics GCSE atomic structure. Now before I go forward, I would really appreciate if you can just like and subscribe my channel if you find the videos useful. Now, going on to the big question, what is an atom? What actually is it? Now, an atom is the smallest part of an element that can exist and still keep the properties of that element. So if you take gold, for example, one atom of gold is still gold. Atoms are incredibly small. They're like about 0.1 nanometers in radius, which is about 1 times 10 to the power of minus 10 meters. That's like tiny, tiny. Millions would fit across the width of a human hair. Now, something students often forget is that tiny atoms are mostly empty space. The mass is concentrated in a tiny central nucleus, and the electrons are spread out around it. The nucleus contains protons and neutrons, and the electrons move around the nucleus in shells or energy levels. So when the exam question asks what an atom is, please don't overcomplicate it. Keep it clear. An atom is the smallest part of an element made up of protons, neutrons, electrons with tiny central nucleus. Now let's break down the subatomic particles. There are 3 main particles you need to know for AQA GCSE and relevant to other boards as well. Protons, neutrons, and electrons. Now, protons have a positive charge of +1 and a relative mass of 1. Neutrons have no charge and also a relative mass of 1. Electrons have a negative charge and a very tiny mass, 1 over 1836 of a proton, so very, very, very small. Protons and neutrons are found in the nucleus and electrons are found in the shells around the nucleus. Now, the atomic number tells you how many protons an atom has. This defines the element. The mass number tells you the total number of protons and neutrons. In a neutron atom, the number of protons equals to the number of electrons. That is a neutral atom. That's important for us to understand. If an electron is lost or gained, the atom becomes charged, and we don't call it an atom anymore, we call it an ion. Going on to the evolution of the atomic structure, very important, and we get a 6 marker, 5 marker, 4 marker on our GCSE questions. Now, atomic theory didn't just happen over time, it developed over the years. Now, Dalton first suggested atoms were tiny solid spheres that couldn't be divided. Then Thomson came in that discovered electrons. He proposed the plum pudding model. Make sure you learn about them. It's a positive sphere with negative electrons embedded inside them. However, Rutherford came up with a gold foil experiment that changed everything. And most alpha particles passed straight through the foil, but some were deflected at large angles. So this showed how most of the atom was an empty space and was not a sphere. It was small, dense, positively charged nucleus in the middle. Then comes the Bohr model. He improved the model further. He suggested electrons orbit in the nucleus or outside in fixed energy levels or shells. Finally, we have Chadwick, who discovered the neutron, explaining the extra mass of the nucleus. Now, all boards love asking questions about why the models changed and how they changed. Also mention the experimental evidence, especially the gold foil experiment, guys. I am hoping this is making sense. You can stop the video and obviously rewatch it if something does not make sense. Have your notes ready, have your notebook and your pencil ready every time I do any video. Now, let's talk about... And lastly, what I want to talk about, you really need a notebook and a pen here, okay? Now let's talk about exam skills. A very common question is describe the structure of an atom. You must mention things like protons, neutrons, electrons, nucleus, and mostly empty space. Another favorite is that Rutherford's gold foil experiment. You need to explain that most alpha particles passed straight through, some were deflected, very few bounced back. This shows that it's small, dense nucleus. They may also ask you to calculate neutrons. Now, neutrons is mass number minus the atomic number to give you neutrons. You could also get asked about what an isotope is. An isotope is an atom of the same element with the same number of protons but different number of neutrons. Finally, examiners often ask why models change. The key phrase is new experimental evidence led to new models, obviously. If you remember the evidence behind each model, you will secure those marks. Now, Also remember guys, if you find these videos useful, please go and subscribe. It gives me enough confidence to keep making new videos and helping you guys. Thank you.